Okay, so for the first question, we have to write a C program that uses a finite state machine to identify the number of occurrences of the string tete in a word. The program should count overlapping occurrences. For example, there's one occurrence of tete in the word metete. However, there are two occurrences in the word metetete. Okay, so I started by drawing the finite state machine. So let's have this one be A and the output 0. Then if you get a T from there, it puts you into state B, which also is an output of 0. You get an E, it puts you into state C, which is 0. Then your state, if you get a T again, D, 0. Then lastly, if you go to state, if you get another E, it'll put you in state E with an output of 1. So now for the rest of it, so to make it so that you can do it back to back. So if you get a T, it'll put you back to here. And then anything else, it'll put you back to this. But that is A. If you get a T here, you get another T here, it'll go back to there. And then you get T here, it'll loop at state B. And I think these are the important ones. So anything else from here, it puts you at state. Go back to state A, same with this. Same with this. Is that all the circles for it? Or all of the diagrams of A?
I think so. Wait, how
come? Okay, and for C, it puts it back when it's 0, or when it's E, it goes back to state A. All right, I think that's it.
All right, so what's it called? You said from state E to state D, it's T, right?
State D to state E?
No, E to D.
Oh, E, yeah, that's T.
How come it doesn't go to B when it's T?
Because
yeah.
Because it's supposed to read overlap. So imagine if it's
okay,
like Tay, so that's 1. But then if it's that, it's this one and this one. So it goes back to there to then go forward to count for another 1.
All right, got it.
Okay, so and then this transition table is based off of this diagram that I drew. I might have missed some, like any other letters, but any other letters will go back to state A because they're not T or E in the right spot. Okay, so then you need to include the standard input output, and then you define the state. So you only need 2 because there's, even though it's te, it's repeating the T's and the E's. So you only technically need it once. So then you need to define if it's any other thing, and then the end of file.
EOS is end of file, right? Or end of string?
End of string, sorry.
All right.
And then you need each one of A is state 0, B is state 1, etc.
All right.
That's how I drew it. So then this is a transition table here based on the diagram, and then here's the output table. The only time it ever outputs 1 is when it goes from state 4 to state 5, or state 3 to state 4, getting an E as the input. Okay, so, oh, I can't scroll down. All right, here we go. Another
You
box.
can erase the table if you want. Yeah, if it gets in your way.
Let's see. I'm gonna just erase just this one.
There's
What
a
does
clear
F
button.
flush do again?
What?
What does F flush do again?
F flush makes it so that if you have a space in it, like you can continue, it gets rid of the space, so you can continue. So I can write Matete and then space Matete if I want. I don't know. That's just how I've written the code for finite state machines.
Got it.
So if you want to, it's a way to do it so where you can scan and also have a space in it. That's what these two combine, like this. Not really sure the logic behind it, but it works. So then I defined the current character, the current state, the string index, the column value, and the count. You need the count for this one because you're counting how many times. So while the current state is not equal to end, so that's this one for the EOS. The current character equals the input string of string index. And then, but you also just, you want to make it all uppercase so you don't have to worry about having lower and uppercase letters. So the 2 upper makes it all uppercase. So then the switch makes it so it lets you have each case equal to certain things. So you just define each of the things up here. Oh, oops. Each of those things. And so if the output table of the current string and the column value equals 1, so that'd be in this case. I put a counter.
Right.
Then the current state equals the transition table of it, then the string index increases. So that just for the while loop. And so if the count is greater than 0, the tete was found blank, or the %d times, the %d would be the count. And then if it's not greater than 0, there's no, tete was not found. And then, so compile it. So let's do, so that's for the first test case, and then the second test case. There you go.
Can you go over the table at the top?
Okay,
Like,
so let me erase it and I'll redraw the table like through like logical thinking.
yeah.
Okay. So you only need 1 T and 1 E. Then we have the \n and A. And then you have state A, B, C, D, E. Okay, so if you're at state A and you get an input of T, it puts you to state B. State E, it stays at state A, state A for anything else. This is always going to be at state A. So okay, so now you're at state B, and you get a T, it goes back to B because it's just finding 1 T. And then, but if you're at state B and you get an E, it puts you at state C. You're at state C and you get a T, it goes to state D. And then you get an E, it puts you back to state A. And then for D, you get a T, and it goes back, puts you to state B. And then if you get an E, it gets you to E, which is where the output is 1. And then if you're at E, if you get a T, it puts you back at D because that's where the overlap occurs. And then if not, if you get an E, it puts you back at state A. And then for this, it's just end all the way down. Okay, so does that table make any sense?
Yeah.
And then if I'll also draw the output table, I'll just keep this. Okay, so the output, oh, that's not fine. Okay, so the only time it was actually outputting 1 was when it was in state E, which is when you're in state D and you get an E as the input. So this is the only one that's 1, the rest are at 0. And then that's always gonna be like that. All right, does that make sense?
Yeah, that makes sense.
Okay. Logan?
Yeah, I got that.
All right, cool. So this is question 1. I want to know if there's a different way of doing it without a counter, but that's just the way of knowing how to count things, count occurrences. So that's what I did.
All right. I'll stop the recording for just